This is the study of geography, and these are the branches of geography: physical geography, human geography, and practical geography. These are among the few topics that we look at when we study geography. We look at industrialization, we look at forestry, we look at tea plantations, maize plantations, brick making industry, among many others. Press the subscribe button so that you can get our notifications. We're very glad that you found time to join us.
Hello learners, thank you very much for finding time to learn with us. We are in our Form 2 work, Lesson 4. We want to talk about the Earth movement. That is where we stopped. We had looked at the plate tectonic theory. Today we want to look at the second theory that explains the movement of the Earth. And we are talking about the plate tectonic theory. Plate tectonic theory is our topic of study. And the plate tectonic theory is an improvement of the former theory of the continental drift theory. What does it entail? What does it say? That the plate tectonic theory says that the Earth, the ground now, the internal structure of the Earth is made up of rigid blocks. Is made up of the seal or the crust. The crust is made up of rigid blocks which float on the mantle. The rigid blocks of the seal and the simmer, that is the crust, they float on the mantle. Now the mantle is in a liquid form, that is what they explain, and it is existing under intense pressure and temperature. Because of that, the liquid is constantly in motion. It is making convectional currents, and these convectional currents, they cause a lot of friction on the floating crust. And so depending on the direction of movement of the convectional currents that are from below now, the crust is forced to fracture. The crust is forced to break into pieces, very large pieces of course. And these pieces now, the fractured pieces, the broken pieces, they make the plates. That is what is referred to as the plates. And that is now what the the plate tectonic theory is talking about. The continental drift theory talked about the steady movement of lands, either towards each other or away from each other. That is continental drift theory. But the plate tectonic theory has gone deeper to tell us that the movement of lands is not just like that. It is the upper layer of the Earth's interior that has broken, and it is moving the crust now. And so we are talking about the crust which is floating on top of the mantle. It is floating because it is made up of very light material, very light minerals, and it is already cold and solidified. It's cold and solid, and so that is why they break when they are subjected to intense pressure. Now, then we talk about the examples of those plates. The examples of those plates. The plates now, the large blocks which form as a result of the pressure that is brought about by the convectional currents which are existing in the mantle. The plates can either be on a dry land, that is dry land, or it can be under the water in the oceans. So it can be an oceanic plate or it can be a continental plate. Now, so we have majorly two types of plates. We have continental, that is the plates which make the continents or the dry land. And then we have the oceanic plates which are found or which lie below the oceans, below the large water bodies. Very good. Any land that is found below a river, for example, we don't count that one as an oceanic, because a river is running on the crust, on the seal. It's not running on the simmer. I think that one we are okay with that. Learners, now we talk about the examples of the plates. What are some of the examples of the plates that we have? We have examples of the continental plates, and we have examples of the oceanic plates. The plates can be large or they can be small in size, depending on where the fracturing took place. Examples of the large plates, large scale now, blocks of land, or of the fractured pieces, include the Eurasian plate. Eurasian, that is Europe and Asia, covering Europe and Asia. The whole of it is regarded as a single plate. Then we have the Australian plate, that is comprising of the Australia as a continent. So that is a continental plate. Eurasian plate is also a continental plate. Very good, because it is making up the continents. Then we talk about the African plate, that is making the African continent, which is the African continent, which is a continent. So it's a continental plate, dry land. Then we talk about the Antarctic plate, that is found in the South Pole. It is also regarded as a dry land. It's not on water. Then we have the North American plate. The whole of North America and Canada is regarded as one plate, and that is a continental plate, very large in size. And then we have the South American plate. That is the South American continent. You see, all these large continents, they form the continental plates and the large continental plates. Beautiful. Then we have the Pacific plate, which is an oceanic plate, and it is found below the Pacific Ocean. Remember, the Pacific Ocean is the largest water body that we have on the Earth's surface. Very large, running from the western part of the Asian countries like Japan and Korea, all the way to the eastern, to the western coast of North America, or the Americas, the western coast of the Americas, running all that way until you come to the eastern coast of the Asian countries. It covers a large area, and we have said it's the largest water body that we talk about when we are talking about water bodies, oceans. That is a topic in Form 3. Now, we talk about the smaller plates, the smaller broken pieces of land and oceans. So we have the Arabian plate, which covers the Arabian countries, very small in size. We have the Caribbean plate, we have the Scotia plate, we have Cocos as a plate, we have the Indian plate. I think we all know where India is found. India is a continent, so that small part, that's a continental plate. Then we talk about the Nazca, is found in South America. On the western coast of South America, we have the Nazca plate. very small in size. We also talk about the Philippines plate. We talk about the Somali plates. So these are small scale plates. Now, the plates as we have seen them, these are the broken pieces of the crust. They are moving, they are not static. And they are moving because there is a lot of pressure from below. Because we said the mantle is hot, existing under very high temperatures and very high pressure. So it is making the material in the mantle to be circulating, making circulations, convectional currents. And these convectional currents, they cause the plates to move. So we are going to look at the types of movement of these continental plates. The plates can either move towards each other, or they can move away from each other, or more, the plates can slide past each other parallelly. They travel past each other in the opposite directions. So it depends on the direction of the convectional currents that is from beneath. Now, the plates which are moving either towards each other or away from each other or past each other, they cause effects. They are effects, and the effects they cause is on the landforms that they lead to. So we have various landforms that are formed as a result of the movement of these plates, and these landforms, they include the rift valleys, the mountains, ridges, all those valleys, all those landscapes that we are able to see, escarpments, they are as a result of the plate, the movement of the plates. Now, when these rigid blocks move, we have said they move away from each other or towards each other or past each other. The edges on the margins now, they move, the effect is felt on the boundaries. So we are going to see the boundaries that are formed as a result of the movement of the plates. The boundaries are three. So we have the extension boundaries, we have the compressional boundaries, and we have the transform boundaries. Those are the three types of boundaries. We have extension boundaries, compressional boundaries, and transform boundaries. Let us have a brief look at the extension boundaries. Extension boundaries are the zones of divergence when the plates are moving away from each other. They are also called constructive margins. That is another name that they are referred to. They are called constructive margins. In this case, the plates, whether continental or oceanic, are moving away from each other, and therefore what will happen is that when they are being extended, that's where we get the word extension from. They are extended, so they leave a gap, they leave an empty space, and this empty space gets filled up with material from the inner mantle, from the mantle. Now, this material, when it comes to fill the gap, it is cooled down and it solidifies and it forms landforms. And so we call them constructive margins. In this case, they are constructing new landforms, new land features are being constructed. So they are either called extension because of the extension that is involved, or they are called constructive because they construct new landforms. Beautiful. Now we have examples of this, that is the Americas, that is North America and South America, is being pushed to the west, and Africa and Europe, they are being pushed to the east and northwards. So at the center, that is in the middle of the Atlantic Ocean, there is a lot of tension, and the land there has been split, the land there has been broken, and new features are being formed. That is what is forming the mid-Atlantic ridge. That is a low-lying submarine mountain that is not yet exposed to the surface. Maybe in the near future, the ridges will be exposed to the Earth's surface. And that is the extension boundary. Now let us talk about the compression boundary. The compressional boundary is also referred to as the destructive boundary. Why? Because the plates are being pushed towards each other. And as they get pushed towards each other, what happens? The land is collided against each other. The land breaks further. Features which have been formed there, they get broken, they get destroyed. So it is compression, compressed, and destroyed. So it's a region of subduction. It's a region of destruction of the former landforms. And it depends on which type of plate that was involved. For example, if we have an oceanic plate being pushed towards a continental plate, what will happen is that the oceanic plate is dense. It is made up of silica and magnesium, as we saw it in our early lessons. And the continental plate is made up of silica and aluminium. So the aluminium is light. It is forced to fold. So the continental plate will fold and form fold mountains, while the oceanic plate will sink. And so we shall have the formation of fold mountains on the side of the land as the sea forms a trench because of the sinking of the land, because the rocks there are very dense and the minerals are very dense and strong. And so that is when we have compressional boundaries. At the compressional boundaries, you will find fold mountains, because if the land that was involved was continental and oceanic. A good example that we have is the Andes Mountains in South America. We have the Rockies in North America. We have the Alps in Europe, and we have the Atlas in North Africa. When the lands are being pushed against the oceanic plates, the lands will fold and they form the fold mountains. Then we talk about compressional boundaries which occur when there is a land that is being pushed against another land. Continental plate against another continental plate. Actually, the African plate and the European plate is a very good example of continental plates being moved towards each other. And in this case, the pressure causes the margins of the two continents to fold. And that is why we have the Alps and the Atlas. Though we had said earlier that the Alps and the Atlas have also been formed because of the presence of the Mediterranean Sea. The Mediterranean Sea is lying on what? On an oceanic plate, which is very dense. Now, then we talk about an oceanic plate being moved towards another oceanic plate. Now, what will happen here is that the two plates are very dense. The minerals are strong and heavy. So what will happen is that they will be forced to move downwards, sink deep into the interior of the earth, and therefore they will form the deep oceanic trench. That is how the oceanic trenches are formed. So when you look at the oceans, you see flat water at the surface. You see, should you never think that the floor of the ocean is flat? It is not. It is made up of hills, mountains, trenches. It is made up of all forms of landforms that we are able to see here on the surface, but then they are covered by the water. And the water, because it is a liquid, then it makes a level line. Thank you. Now let us talk about the transform boundaries. These ones, they form where the lands are moving past each other, and in this case, at the margins, there is no destruction of any landform. They only move past each other where there is a transform fault, a very large crack, and the lands there, the landforms there are conserved. So we call it a conservative margin because it is able to conserve all the former margins, the former landforms. And that is the end of our lesson, and thank you very much.
Continue watching this YouTube channel where you will get more similar content to help you during your study in high school, and kindly share so that your friends can get the same kind of content and be helped in their study as well. Thank you. Have a nice time.